In this video, I'd like to talk about multiplying variables. Now, up to now, we've hit very hard this concept of not being able to combine unlike terms. When two terms are unlike, you cannot combine them. Okay, so for instance, like A plus B. If you don't know what A is and you don't know what B is, you can't combine them, okay? You could combine A and 3A, okay? And that would make 4A, okay? So these are like terms, but if you add an unlike term, you can't do it, okay? Also, by the way, A squared is an unlike term to A. You cannot add these together. They're unlike terms. Why? Because this is A, this is just A by itself, but this is A times A. Okay, this is A times A being multiplied. PEMDAS says you need to do multiplication before you do any addition. Since you don't know what the value of A is, you're stuck in the mud. You cannot do anything further than that. And because you're stuck here and you're frozen in time, you can't even get to the addition step, okay? So that's why this is considered a different term. Multiplication is a much stronger bond than addition is. And so this stronger bond comes first, and before that stronger bond can get taken care of, it cannot be added to anything else. All right, so what if we have multiplication, okay? So multiplication does not fall inside this you can't add or subtract rule, okay? So you cannot add A and A squared. You cannot do that, okay? But, so you cannot combine these through addition or subtraction, okay? But you can still multiply them. You can still divide them. So this, when we talk about you can't combine like terms, we're just talking about you can't add and subtract. Multiplication and division, that's fine. That's fine, okay? So if you had A, not plus, but times A squared. Yes, we can do something here. We can multiply. This is A times, and this is A times A. A times A. All right, so now we have A times A times A. Well, that's another way of saying A cubed. All right, so it's totally fine to multiply unlike terms. And let's say that we had a 3 here. What would that look like? Again, all we're doing is multiplying. A cubed is just a lot of multiplication. A squared, just a lot of multiplication, and then you're just multiplying them. So everything here is being, and is just involving multiplication. There's no addition. Okay, so here this is like triple A times A times A, and then this is double A times A. It kind of sounds like baseball teams. All right, so now there's 1, 2, 3, 4, 5 A's being multiplied against each other. So that's A to the 5th. That's represented with A to the 5th. The 5 here is called an exponent, and it tells us how many times the variable, in this case it's A, is going to be multiplied against that same variable. So A is going to be multiplied against A 5 times over. Okay, so this is the exponent. This is called the base. So think of it as like the bottom of a lamp, the base. So whatever this down here is called the base, and the exponent tells the base how many times the base needs to be multiplied against itself. Okay, so what if we had not only different terms like this, but different variables also? Okay, so if we have x times y, so this dot is a multiplication sign, we don't even need to have this dot here. It's implied. So a lot of times there's multiplication going on in problems, and there's not even a dot there, okay? So what we need to do is, we need to think of them as just being multiplied against each other, whether or not there's a dot. So x times y, we can do something. We can call that xy, okay? That's totally fine. That's absolutely fine. We can't go further than that, but that's as far as we can go, and that's totally fine, okay? If we had x times y times z, that would be x, y, z. All just multiplied against each other, okay? I mean, you could give them, if they had numbers, let's say it was 2, 3, 4, it would be 2 times 3 times 4. Okay, that's fine. Now, if you knew their actual values, then you could then multiply them. That's great. That would be 24. But the point is, if you don't know what the values are, you can keep them like that, and it's totally fine. Okay, so let's do a problem where we are doing some distribution with, let's do this. How about this, and that, okay? We're going to distribute this x over everything. So this is going to be x times x squared, that's x cubed, plus x times x is x squared, plus x times y is xy. Oh, the other thing I want to say is xy could be also yx. So it doesn't matter. Just like 2 times 3 is the same thing as 3 times 2, it doesn't matter which order you put them in, because they're all being multiplied against each other anyway. Okay, so I'll give you a couple problems to try to practice and hone your skills on multiplying unlike terms that have different variables and the same variables. Thanks.